All right, let's look at homework 10.4, problem number 6. All right, so let's find the radius of convergence of this function here. All right, so radius of convergence, so ratio test, you have a limit as n approaches infinity, absolute value of, all right, so you have an would be x to the n plus 1 over n plus 1, 3 to the n plus 1, and divide by the reciprocal of that, so n times 3 to the n over x to the n. Right? Let's clean it up. All right, so you have, let's see, so 3 to the n and 3 to the n plus 1 cancel out, so there's going to be a 3 left over. All right, then we do the same thing, x to the n, you have x left over. All right, so I'm going to, since those two guys are just has nothing to do with n, so I'm going to pull them out. So this is going to be equal to absolute value of x over 3, right? Then you have a limit as n approaches infinity. And what's left is, let's see, there's an n on top, and then you have n plus 1 on the bottom. So you have n over n plus 1. Right? So as usual, I'm going to do the trick. I'm going to divide top and bottom by n, and we have absolute value of x over 3, and the limit as n approaches infinity. Right, so n divided by n is 1, and n divided by n is 1, plus 1 divided by n is going to be 1 over n. Right? Then as n approaches infinity, this guy approaches 0, so you have 1 over 1. So this is just absolute value of x over 3. All right, then in order to get a convergence, we have to make sure that this is less than 1. So if you multiply through by 3 so that we can get rid of that 3, absolute value of x is less than 3. Right? So we know that the radius of convergence is 3. Right? So let's type it in. All right, radius of convergence is 3. And the derivative is the same radius of convergence, and the second derivative is the same, and the antiderivative the same. All right, so let's check the answer. All right, I came back and looks like we got all 4 correctly. All right, that's it. I hope that this was clear.